All right, so I'm going to go over some of the homework problem. I'll just do all of them because there's not that many. From the section on infinite limits and limits at infinity. So the first three problems are actually just infinite limit problems. So again, this is like vertical asymptotes. What we're looking for, I always just factor these to begin with. This is going to be what, x minus 3, x plus 2 over x plus 5. In general, we know that there's going to be a vertical asymptote wherever we can't cancel something that's in the denominator. So this tells me, looking at the x plus 5, it tells me that at negative 5, there's going to be an asymptote. But I can just justify that using limits. So I can say, well, as I approach negative 5 from the left, x minus 3, x plus 2 over x plus 5. I know that if I substitute, I'm going to get 0. If I put in something that is just to the left of negative 5, or coming from the left, that's going to give me, well, something negative times a negative over another negative, which is going to be positive over negative, so that's going to give me negative infinity. And if I take the limit as x approaches negative 5 from the right, these problems are a lot easier to do, the sort of numerical analysis part, if you factor it first, because then you can just very quickly figure out if you're going to have a negative or a positive. So I've got negative, negative, so negative times negative, but now put something just to the right of negative 5, so I'm going to end up with a positive number down here. Positive over positive is going to give me positive infinity. So looking at this, limit from the left is a negative infinity, limit from the right is positive infinity, so I can say, therefore, I'm going to have a vertical asymptote at x equals negative 5. It doesn't matter that it's going to negative on one side and positive to the other. And technically, just showing that one side is negative infinity or one side is positive infinity is enough. Just for the sake of completeness, I'm going to show everything. Okay, I'll do the same thing factoring here first. So I end up with x minus 5 over x plus 2 times x minus 1. I'm going to have two different vertical asymptotes in this problem, one at x equals negative 2 and one at x equals 1. So I'm just going to do one of these. I know this is kind of tedious. Let's say from the negative side, x minus 5 over x plus 2 times x minus 1. That's going to be negative 2 minus 5. That's going to be negative, or something just to the left of negative 2. That's going to give me a negative here and a negative here. So negative over positive is going to be negative infinity. And if I come, and so that's enough to tell me that so I can say, therefore, there's a vertical asymptote at x equals negative 2. Again, I'm just not bothering to show from the right-hand side of negative 2, because it's going to be either positive or negative infinity. I don't really care which. This is enough to tell me that there's a vertical asymptote there. Okay, limit as x approaches 1, so 1 is going to be my other vertical asymptote because I've got another uncanceled factor in the denominator. X plus 2, x minus 1, and so here I'm just going to do I'm just doing it from the left. So again, x approaches 1 from the left. If I put that in, I get a negative over positive times negative. So it's going to be negative over negative, which is positive, so I get positive infinity. So I can say, therefore, there's a vertical asymptote at x equals 1. Okay. This is, do I know already? Yeah, I mean, I know already that there's going to be an asymptote just by looking at the fact that there's an uncanceled factor in the denominator. What I'm doing here is showing what I need to show in order to justify my answers using limits. Okay. This one is going to also have two asymptotes. I'm not going to worry about that. Or no, it's only going to have one, I think. I'll let you guys work on that one. I want to get to some of these because I feel like these are the limits at infinity. So this is where we're looking at x going to negative infinity or positive infinity. So let's look at this guy. Okay. We don't have anything weird with square roots or anything, so I'm not going to worry about that. I'm just going to multiply by 1 over the highest power in the denominator. I'm which case is x squared. So 1 over x squared, 1 over x squared. I end up with the limit as x approaches negative infinity. I want to keep track of that negative infinity. But I get 3 over x, 2 over x squared, minus 5. The denominator, I get 2, minus 3 over x, minus 1 over x squared. Now I can evaluate. I get 0 plus 0 minus 5. 2 minus 0 minus 0. That's going to give me negative 5 over 2. There's my answer. Same thing here. Highest power is x squared, so I'll do 1 over x squared, 1 over x squared. That'll give me the limit as x approaches. Now I'm going to positive infinity. And here it didn't matter that I was doing negative infinity because I had it over 3 over negative infinity is the same as 3 over infinity. It's going to be 0. Okay, so I've got 3 over x plus 5 over x squared. Then I've got 2 minus 3 over x here. So this now I can evaluate. I'm going to get 0 plus 0 over 2 minus 0, which I'm sure that's going to be 0. And that's our old rule. This is, again, we're using limits to show something that we already knew that we learned in Algebra 2, which is if this is a bottom-heavy function, the degree is greater in the denominator, then the limit as x approaches infinity is going to be 0. Okay. Number 6, we've got negative infinity. So I'm going to multiply by highest power is x in the denominator, so 1 over x over 1 over x. I get the limit as x approaches negative infinity of negative 2x plus 5 over x over 3 plus 2 over x. And I substitute this in, negative 2 times negative infinity. So negative 2 times some really big negative number is going to be some very large positive number, infinity. 0. 3 is just 3. 2 over infinity is going to be 0. Infinity divided by 3, still infinity. So this goes to positive infinity. Now we got some of those nasty square root problems. So this is 7 and 8 from the homework. Okay, so going towards negative infinity. This is important. So in the denominator, I know I'm going to have to do square root of 1 over x squared. Because I'm going to negative infinity, I'm going to have to do negative 1 over x in the denominator. Again, because I know that as x goes to negative infinity, the square root of 1 over x squared is going to be negative 1 over x. Not a negative number, but the opposite sign of whatever x value I put in there. Okay, we get limit x approaches negative infinity. We get negative 2 minus 1 over x over the square root of 1 minus 1 over x. Now I can substitute. I get negative 2 minus 0 over the square root of 1 minus 0, and that's going to be negative 2. Oh, I'm using my red pen. I'm going to use the black pen. No, sorry. All right, over here, square root of x squared. So I'm going to do square root of 1 over x squared in the denominator. Now in the numerator, look here, I've got x goes to positive infinity. As x goes to positive infinity, this square root of 1 over x squared is just going to become 1 over x, positive, right? So, do my multiplying thing, x goes to infinity, blah, 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 negative 2x plus 1 over the square root of 2 minus 3 over x squared. Alright, now I can do my substitution. Negative 2 times positive infinity. So negative 2 times some very, very large number is going to be some very, very big negative number. So negative infinity. 1 is just 1. 2 is just 2. 3 over infinity is just 0. So I get negative infinity plus 1 divided by the square root of 2 is still going to give you negative infinity. Really big negative number. So there is, okay, that's horrible. Let's just scratch that out. How about that? Woo, done. This one was negative 2. All right, there you go.